Eyes up here. Eyes up here. What do we think? What do we think this is?
7/10.
Oh.
Oh, get it right.
How do we get 7/10?
You find the square root of the I can't remember what that's called.
Perfect square.
No, the number.
Like numerator, denominator. Okay, so Elliot's saying, well, we can find the square root of the numerator and the square root of the denominator, and we get 7 and 10.
Wow.
That is exactly right. Okay, so what? Well, yeah, but this is under a radical.
Give me back my pencil.
This is pulled out of the radical.
Oh.
Like, let's see.
Go get it. Go get my pencil.
So it's very frustrating to me that there's so much noise. So the square root of 49 over 100 is 0.7, which is the same as 7 over 10. Isn't that kind of cool? Okay, now, so what I want you to understand is that up here, if we have the square root of a over b, it really means the same as the square root of a over the square root of b. You can go back and forth either way. Okay, so look at number 3. What do you notice about number 3? Anything? You can't square root the 3. However, we have that 16. What?
Not on your feet. It's on the floor there. You see the shiny thingy?
Yeah. So we have the square root of 3 over the square root of 16, and we know that the square root of 16 is
4. 29.
That's 3/4.
3/4 is just
the radical needs to remain with the 3, but since the square root of 16 is 4, the radical is not there anymore. Okay. Do you have a question? What?
I'm gonna kill your water launch for that.
At 1:15. Okay.
Oops. Are we solving that?
So I'm going to give you a number and I'm going to send you to one of the vertical whiteboards. And I want you to see what you can come up with for 5 and 7. Okay. Ready? 1, 2, 3, 4. 5, 6, 7, 8. 1, 2, 3, 4, 5. Yes, you're 6, and you're 7, holding your 8. Okay, and you're 1. J of 2, Maddie 3, Avery 4, Greg 5. Go! You have 2 minutes, go! Bring a marker, bring an eraser.
1.
I haven't told you how to do these problems, but I think you can figure it out.
4.
Yeah.
Oh my.
There's one right here. There's one right here.
I'm
know my face. We did that problem.
All right, let's go ahead and go back to seats. Let's go back to seats.
They're gonna be knocked out.
Okay, I see a couple right answers. Okay. Okay. So I noticed, this is very interesting. So I noticed over here that they said, ooh, 45 is 9 times 5. So they brought the 3 out. But then they also noticed, oh, 10 and 5 are both under the radical. And so if I take 10 divided by 5, it's 2, and we can stay under the radical.
I didn't get that far.
Is that right?
It's right, except for the fact that the 3 is in the denominator and should stay in the denominator. Okay, so this radical 2 over 3, that's actually the right answer. Okay. So let's talk about what this group 3 did right here. They said, hey, and maybe you should write this down with us. 45 is 9 times 5. So I bring out the 3. And then we can put 10 over 5 under the radical. And what's 10 divided by 5? So square root of 2 over 3 is what our answer is. Okay. You don't like fractions? So maybe you would like this better. Maybe we just go straight to, this is the square root of 10 over 45. And we reduce 10 over 45. Well, they're both divisible by 5. So 2 over 9. Okay, so we have the square root of 2 over the square root of 9. Is that better?
Yeah. That's awesome.
You like that one better?
That was the way I did it.
Okay, so this is maybe a little bit more efficient. So maybe if you like that way better, let's get rid of the teal. And let's go with what's in red. Does that sound okay?
Yeah.
Okay. So based on what I just did in number 7, or excuse me, in number 5, does anybody want to change the process of how they did number 7? I'm fine with the long answer. So group 3, once again, went about it in the same fashion they did the first one. Okay. What can we do with 96 and 3? We can actually divide them. Since they're both under the radical, we can actually do the division. What is 96 divided by 3?
32.
Ooh. Hey, we no longer have a fraction.
Yeah.
So we know that 32 is 16 times 2. So we now have 4 radical 2. Reagan, you don't like that?
No.
Okay, are you okay with how I got 32? No?
Yeah. Because you did 96 divided by.
Okay, so now 32 is under my radical. So I know I need to find a perfect square that divides into 32. Well, I know that 16 times 2 is 32. So the square root of 16 is 4.
Funny.
Hey, now, would it be efficient for us to do that same process in number 6? Why did you say no? Somebody said no. Why, Abby?
Because you can't directly divide those two together.
That's okay. We couldn't, I mean, 10 over 45 we reduced. Peyton, do you have an idea? Oh, okay. 3. Hey, can you look up here?
Yeah. 1/3.
Like 4.
Division. 5 to 2.
People, do we know what the square root of 36 is? Stop making this problem so complicated. The square root of 36 is 6. Should we? Okay. Now, just like multiplication, we can divide underneath the radical and we can divide outside of the radical. So this 2 divided by 6 is the same thing as 1 divided by 3. So we wouldn't really have to write the 1. Yes.
Never. Oh, absolutely no.
I am a little confused. Okay, I'm having a hard time understanding Amelia's question, and I think some of it is I'm trying to drown out your noise. Stop. Mhm. So think about 2 over 6. They're both divisible by 2, so it becomes 1 over 3. So this 2 over 6 becomes 1 over 3. And then the radical 3 is just still there. Okay. Do I need to move you?
I did not say something.
It's just a question. Do I need to move you?
I don't think so. I didn't say nothing.
Okay. Okay. Now, here's the deal, and this is something that you're really gonna need to know how to do. Okay. It is not okay to leave a square root in the denominator. Do you see number 13, that 4 over radical 7? That's not okay. Now, over here on the page before, there were strategically numbers put together that we could divide underneath our radical. Okay. Well, that's not always going to happen. So when we have a radical in our denominator, we need to do what's called rationalize the denominator. And when I ask you to rationalize the denominator, you are going to multiply both the numerator and the denominator by the radical that you no longer want in the denominator. Okay. And these are the kind of problems we're going to finish out our day with. Okay. So first of all, just write down what I'm asking you to write down. To rationalize the denominator, we are going to multiply numerator and denominator by that radical that is in the denominator. We don't want a radical in the denominator. Not okay. Right. So, tell me what that means. Do we have a radical in the denominator? Yes. Okay, so we need to rationalize the denominator. If I need to multiply numerator and denominator by the radical that we have in the denominator, what is that radical? So since we have a radical in the denominator, we are gonna take this radical and we're gonna multiply it. Now, we can't just multiply by radical 7, but if we multiply numerator and denominator by the same number, it's like we're multiplying by 1. And if we multiply by 1, are we changing the value?
No.
We are not.
Why is math so sneaky?
Exactly.
Why do we have?
This is just the tip of the iceberg with sneaky math.
It's like this counts this, really.
Okay, so we're multiplying by 1. Nothing is changing. It just looks differently. So in our numerator, when we multiply, we get 4 radical 7. Watch this. And this is why we're doing this. What is radical 7 times radical 7? Radical 49, which is right? That's it. That's the answer. What?
The UV is 8.
What?
The UV is 8.
Okay, so let's look at number 14. Silently try number 14. Just silently try number 14. Think of those nice farmer tans you're gonna get in the track meet today.
You should have seen mine on track. It was so bad.
No, me and Reagan, we did this thing called hide behind something and then tan. So what? We just rip off our uniforms and go tan.
What?
That is totally on the video.
Wait, what? Oh my goodness.
Like I am literally recording right now.
This helmet. That was from Saturday.
All right, Preston, what did you get for your answer? Yeah, Avery got us a little distracted. We're doing this problem.
Yeah, she got me very distracted. Wait. Oh.
You have an answer, Peyton? Peyton got radical 10 over 2. Oh my goodness! I didn't get that. Okay, eyes up here. Eyes up here. So if we have a radical in the denominator, it's not okay to leave it. And 5 over 2, like we could divide 5 over 2, but that's not anything special either. So we are going to multiply both numerator and denominator by this pesky radical that's in the denominator. Radical 5 times radical 2 is radical 10. Radical 2 times radical 2 is radical 4, which then simplifies to 2. Can I divide this 10 and 2 to be 5?
No.
Why?
Because there's a radical at the top.
Because there's radical with the 10, but there's not a radical with the 2. What? Because it was radical 4, and we know that the square root of 4 is 2. Okay. Okay. Let's talk about number 15. So this is a radical with a fraction underneath. Can this fraction be reduced?
Yes.
To what?
9, 2.
I have
9 over 2. Radical 9 over 2. Got it. Thank you, Kate.
No, you're not saying it right still.
9 over radical.
So we can break this up into numerator and denominator have their each radical. And I think you were trying to tell me that the square root of 81 is 9, but
Sure.
then 2 is still under the radical. Is this what you were trying to tell me?
Sure, yeah.
Okay. Now, since we have a square root of 2 in the denominator, Preston, what do we need to do?
Multiply the 2.
Okay, no, that's right.
Yeah, that's right, Paul.
Dang.
So we have 9 radical 2 over,
I don't know why I said 4.
well, we'll say square root of 4, which is 2. Yes, my dear.
So you made it into a 9 over 2 because it's a perfect square.
Since 81 is a perfect square and it's under the square root, we can say that the square root of 81 is 9, and now there's no longer a radical.
Okay. And then you do the like multiplying and radical to like
Okay, you try 17.
I don't wanna. My brain is just raining right now. No, I haven't had it. What is that market from?
You know what I mean? You know what I mean?
That is not what I've been done. That's not what I.
So, no, that's not.
I don't know.
Stop. Gus, Stinky, stop.
Are we doing anything tomorrow?
Yes.
Are you doing anything tomorrow?
Oh,
Is it a dance?
Why is Matt Bates after weekend though?
yeah.
I don't know.
Yeah, but he's hurt.
It looks like your handwriting.
So it sounds like we're done with this problem.
I know, I don't know.
4 radical 6 over what? Okay, let's talk about how she got that. What'd you do first?
I multiplied by the radical of 2.
Okay, so we got 4 radical 6 over radical 4, which is how she went to this 2, but this is not the final answer.
You can divide it.
Okay, do you notice how outside of the radical we have 4 divided by 2? What is 4 divided by 2?
2. I had it right.
2, 6.
I had it right, and you made fun of me, and so I unfinished it. No, you got. No, it was not.
So,
It was not.
so we have to go one more step. Okay,
This is like the worst lamb area.
this is the worst one all week.
It's just like the most confusing.
Okay, I want to do number 18 now. Okay, so first of all, under the radical, I have a 4 in the numerator, and under the radical, I have a 3 in the denominator. Is there anything that we can do with those? Like with division, we can't. Like if we had a 10 and a 5, we could like divide them, okay? But that's not what we have. I don't know what's happening over there. And it's fine.
Sorry to.
Okay.
Abby kicked it.
But we have, was that necessary right now? We have a radical 3 in the denominator and it's not okay, but also people, what is our numerator?
A number.
Two.
I want to play this.
Radical 4 is 2. So can we go ahead and just do that real quick? I'm not done yet. We're not done. Now, we need to rationalize the denominator.
Right there.
So our numerator is 2 radical 3. Do I need to keep you after school because I keep having to pause to wait for you to be quiet?
No.
Because that's really where this is heading. In our denominator, we have 10 radical 3 times radical 3. So what, 10 radical 9? Okay, so our denominator becomes 10 times 3. Because we know that radical 9 is 3.
Oh, okay. Actually, got that now.
Okay, now, hey, I'm not done. Why am I not done?
You didn't circle an answer.
2 over 30 is 1 over 15. So our answer is radical 3 over 15. The bell's not even close to ringing. Your homework is page 14. Oh my. I didn't do the whole thing. Shoot. Hold on. Forgot there were more. Okay, you know what? I want you to do just the odd problems of both pages. Just the odds. Both pages, just the odds. So page 14 and 15, just the odds.
He's here, I just don't know if he'll be.
So that's 12 problems.
No.